Hi, I'm Thomas. I did the bill of materials, soldered the resistors and the LEDs, and did the schematic.
I'm Lindsay. I soldered the accelerometer, sourced parts, and did the mechanical drawings.
I'm Tristan, and I wrote the code.
I'm Ivan. I did the block diagrams and the interface definitions.
The POV wand features an MPU 6050 accelerometer to determine its direction of travel. It uses a potentiometer for variable refresh speeds. It is designed to spell any length of word, given enough travel.
For our POV1, we have a sensor block made up of an accelerometer and a potentiometer. These feed into an UNO microcontroller block, which then outputs an 8-bit bus to power the correct LEDs. The user inputs into the system through the sensor block. The I2C signal from the accelerometer is read into the microcontroller to get data on the direction of the device and make use of the analog input of the potentiometer to adjust the refresh rate of the characters being displayed. This then allows the microcontroller to send the 5-volt signal to the correct LED to display a character.
After the block diagram was completed and the interface definitions were finished, the next task was to associate physical pins on the microcontroller to the proper inputs and outputs of the LED block. Starting with the inputs of the system, the sensor block contains two components, a potentiometer and an accelerometer. Potentiometer allows the user to adjust the speed of the LED refresh, and the accelerometer gives the microcontroller directional data. In between the input and output, the microcontroller fuses the potentiometer and accelerometer data to compute proper timing and translates that to signals on the LED pins. The LEDs require a resistor in series with them to control their current. The resistor value is calculated using Ohm's law and Kirchhoff's voltage law. From the data sheet, we can know that the LEDs have a forward voltage of 1.8 volts and the current through them is 7.5 milliamps. This means to get the correct voltage and current, we need 7.5 milliamps and 3.2 volts across the resistor, assuming the microcontroller does 5 volts. Now, using Ohm's law, we got that R needed to be 430 ohms. However, 430 ohm resistors were not readily available, so we opted for a 100 ohm plus a 330 ohm resistor in series to get the proper resistance. After the schematic is defined, the hardware can be laid out and put together.
These are the mechanical or technical drawings from 3 views: front, back, and side. Here we have the potentiometer, 9-volt battery, Arduino Uno microcontroller, and a protoboard. On the protoboard, we have an MPU 6050 accelerometer and gyroscope at the top. Below are 8 LEDs that pass through our acrylic wand.
The code was designed to be tested before any input or output hardware was available. This was accomplished by separating the code into a test portion that uses a serial monitor for output and simulated values for inputs, a production portion that uses ports to get input and output, and a generic portion that contains the general algorithm and pointers to test and production-specific code. The portions are switched between using a define statement and if-def checks. The general algorithm is a state machine that switches between writing segments and determining the direction to write the next letter. The segment writing state required no delays when reading the direction of travel, so that segments could be written out as fast as possible, requiring the checking of the time at each iteration. As you can see, the wand can consistently display 7 letters. We also have a variable refresh rate.
For our next steps, we think it's a great idea to add more aesthetic enclosure for our device.
We would also like to add an option for user input to write text to the display.
We like to add RGB and image support to create colored pictures.
Additionally, it would be nice to have automatic variable speed so that users could wave it at any speed.